Okay, so our question is, what is the osmotic pressure of a solution containing 7.10 grams NaCl or sodium chloride in 100 milliliters of water at 25 degrees Celsius? So we see here we're going to be calculating osmotic pressure. That means you're going to be using our osmotic pressure equation, which is I equals mRT. So we'll go ahead and just list everything out so we can fill them in and just plug them into the equation. Okay, so I is our Van 't Hoff factor. It basically says how many ions we have when NaCl goes into the solution. So when you put NaCl into the water, it's going to break up into a positive sodium ion and a negative chlorine ion. So that's going to give us a Van 't Hoff factor of 2. So Van 't Hoff, we have 2. M is our molarity. And so to figure out molarity, we need to use our 710 grams of NaCl and our 100 milliliters of water. So we have 710 grams NaCl. First step is to figure out how many moles we have, and in 1 mole of NaCl we have 58.44 grams. Okay, so just plug that guy in the calculator, and it's going to give us a value of 0.1215 moles. Alrighty, and so now that we have that, we'll notice that this is in moles, but we need our molarity. So the way to figure that out is just to take this number right here and divide it by the amount of liters of solution. So we have 0.1215 from over here divided by our solution. And you gotta be careful here because this bottom value for molarity is going to be in liters, not milliliters. So it's a simple conversion. There's 1,000 milliliters in a liter. So 0.1 liter. All right, just plug that in the calculator. That'll give you a value of 1.215 molarity. Okay, cool. So now we have our second value for the equation, 1.215. All right, now R, this everyone should know is a constant, 0.0821 liters times atmospheres, K times mole. All right, and lastly we need our temperature. It's given to us in Celsius, but we have to convert that into degrees Kelvin. Simple conversion, we have 25 degrees Celsius plus 273. And that is going to give us 298 degrees Kelvin. There's our last value, 298 Kelvin. All right, now that we have all these values, let's get a clean slate. Okay, and now all we have to do is plug and chug. So we have pi, our Van 't Hoff factor was 2. Our M was 1.215 molarity. Our R is 0.0821 liters times atmosphere over K times mole. And our last value, we're just gonna stick this guy over here. Just know that he's multiplied on. All right, and you just put all those guys in the calculator. It's gonna give you a value of 59.45, and our unit here is atmospheres for osmotic pressure. There you have it. There's your answer.